Hi everyone, in this video we will learn how to prune Docker objects. Docker takes a conservative approach to cleaning unused objects. This is often referred to as garbage collection. Unused Docker objects can comprise of images, containers, volumes, networks, and build caches. Docker does not remove these unused objects unless it is explicitly told to do so. The reason to prune unused Docker objects is a buildup takes up extra disk space. Besides freeing up disk space, pruning unused Docker objects can improve Docker operations, such as pulling, loading, and running containers. We will review how to prune a variety of different Docker objects. Please note, always use caution when deleting objects. Once an object is deleted, it cannot be recovered. Before we get into the code, I will briefly talk about the difference between the prune command and rm and rmi commands. The prune command is used to remove all of a specified object type. For example, running docker container prune will remove all stop Docker containers from the local machine. The rm command removes a specified container, while rmi will remove a specified image. For example, running docker rmi web app v1 will delete the given built Docker image. You can also modify the rm and rmi commands to remove all instances of a given object. As with using prune, if you use rm and rmi, please use caution because when an object is removed, it cannot be recovered. Let us get into the code. I will bring up my terminal. First, I will run docker system df. This will give the most accurate usage of disk space by Docker object. This command lists Docker objects, including images, containers, volumes, and the build cache. We can see the total size for each of the objects, and if they are reclaimable. Reclaimable means the disk space will be freed if the object is pruned. In my case, the build cache is taking a significant amount of space at around 16 gigabytes. Let us start by pruning containers. In my terminal, I can run docker ps, where the ps stands for process status. This will list any containers that are running. We can see there are 3 containers that are currently running. If we run docker ps-a, this will list both running and stopped containers. We can see we have many stopped Docker containers. We can add filters to our prune command. If I want to only prune the containers that are older than 24 hours and that are stopped, I can run docker container -- filter and in quotation marks until 24 hours. We are warned that this will remove stopped containers. To continue removing, we are going to press Y for yes. We have pruned or deleted the stopped containers. Docker also outputs the disk space you reclaimed from removing the containers. If I want to prune all stopped containers, I can run docker containers prune. I will add the -- force flag, which will bypass the warning about removing the containers. We were able to delete the remainder of the stopped containers. We can work on pruning images next. If I run docker image prune, this will clean up all dangling image. A dangling image is an image that is not tagged and is not referenced by a container. To check for dangling images, we can run docker images -- filter, and within quotation marks, dangling is equal to true. We can see that we have 3 images listed as dangling. Let us run docker image prune. Again, I am prompted with a warning. I am going to input Y for yes. We were able to remove the dangling images. I can rerun the filter command to make sure that they were truly deleted. And we can see that they were. If we want to remove all images that are not used by a container, I could run docker image prune -a. Like in the container prune, I can filter based on time, but I am just going to delete all the images which aren't used by containers. I am going to use the -- force again to remove the prompt. We were able to successfully prune the images, and if we look at the bottom, we can see that we were able to successfully delete about 1.38 gigabytes worth of space for unused images. Next, we can work on pruning volumes. Volumes are used to store data generated by Docker containers. There was a change after Docker version 23 that changed the prune command for volumes. A link in the description to the issue on the Docker CLI GitHub page goes more into this topic. Prior to Docker version 24, running docker volume prune would delete all unused volumes, whether they were named volumes or anonymous. In the current version of Docker, running docker volume prune only removes unused anonymous volumes and does not remove unused named volumes by default. This was done to keep users from accidentally deleting their volumes and data. First, I will run docker volume ls to check out which volumes I have. The only ones currently being used are the volumes starting with DC. I will try running docker volume prune. I will put in yes, and we were able to delete one of the unused volumes that is not tagged. If I want to remove both anonymous and named volumes that are currently not being used by a container, I can run docker volume prune -- filter, and then within quotations, all is equal to 1, and I am also going to input -- force. We have successfully removed the unused Docker volumes. Docker networks manage communications between Docker containers and between Docker containers and external networks or machines. Docker networks do not take up much disk space, but they do create IP table rules, bridge network devices, and routing table entries. We can view networks by running docker network ls. To clean any unused networks, we can run docker network prune, and I am going to include -- force. In my case, we do not have any unused Docker networks. Moving on, Docker contains a feature called the build cache. When a user runs the docker build command to create a new image, Docker executes the instructions within the Docker file and creates a layer for each command. For each instruction, Docker checks whether it can reuse the instruction from a previous build. If the program finds that similar instructions were executed before, it can use the cached result. The build cache can save time, but over time, as in the case on this machine, the build cache can take up a significant amount of space. Running docker builder prune will remove the dangling caches. I am also going to add the -a flag to remove the unused build caches as well as the dangling ones. Given the buildup of caches on my machine, this took a few minutes to run, but we can see at the bottom we were able to reclaim about 16.6 gigabytes of space. The final command we will run is docker system prune. This command cleans all unused Docker objects on your machine. It will remove all stopped containers, all networks not used by at least one container, all dangling images, and all unused build caches. We can see that we reclaimed 0 bytes of space using docker system prune because we used the prune command on all of the previous objects. Thanks everyone for watching. I hope that this video was helpful. In the description, I included links to relevant documentation pages for Docker. If you found the video helpful, feel free to like and subscribe. You can also connect with me on LinkedIn, X, GitHub, Medium, and Odyssey. Thanks again, everyone, and happy coding.